that kind of language, seriously. Okay. On it, I wrote outside of the window. That was bad. Let's say, okay, so this is question 39. Sorry for the fans at home, but we made a unit vector by dividing by radical 18, which is the magnitude of vector u. And then once we did that, we doubled it because that's what D asked us to do, is get a length to 2. So sorry, it's kind of hard to read on the video because it looks like it got cut off a little bit there, but oh well. Next question. Okay, question 43. An airplane is flying on a compass bearing of 340 degrees. Okay, alright, so 340 degrees. Let's see, if I go 90, 180, 270, and 340 is going to be like this, right? So the magnitude of that vector is, not 340, what am I writing? That's a bad idea. Well, okay, how fast is this plane moving? 20 miles an hour. Oh, how fast is it moving? Fast. So that's what I'm supposed to write for the vector, fast. 325. Okay, so can you tell me, based on the fact that this is a 340 bearing, what the angle inside this triangle would be that I'm trying to highlight in that corner? So you got 340, but remember that 270 is back here. What's the difference between 340 and 270? Oh my goodness, folks. 70, thank you! Big oof. Okay, so we got a 70 down there. Okay? So 340 take away 270 gave me my angle in my triangle. Hold your calc. The wind is blowing with the bearing 320 at 40 miles an hour. Okay? So, along comes the wind. Okay, now 320, that's going to be a little bit more shallow. Now, I'm exaggerating that a little bit, right? Because this is only 20 in length. Or is it 40? 40, gee whiz. And pay attention to what I'm even talking about. And I'm having a tough time erasing. Yes. Seeing the help document on your laptop? Okay. Have you cleaned off your glass? Yeah, I probably should. You're probably right. Once I get done with it, I'll snapshot it and put it in there. I should have done that with 39, too. Okay. All right, question. So to continue with this, we have added a new vector. Now, keep in mind, if I'm going 325, what if the wind was directly behind me? You would go faster. Now, if you added 40 and 325, what's the maximum speed I could be traveling? 360 miles an hour. But because the angle of the wind is not exactly at my back, we're not going to be at 360. It'll be less than 360. But if it were truly heading in the same direction I was, then it would be adding to my speed, and we could just straight up add the two together. Okay? Can I get it back? Thank you. Oh. 365. I take that back. You are correct, sir. Thank you so much. My max would be, so the max would be 365. but we know that it's going to be less than that. Okay, so what is, if you imagine this to be a brand new origin right here, and this bearing is 320, what would this triangle look like? What would the triangle of the wind look like? We know that it's got a hypotenuse of 40, but what's the angle down here in the corner? 320 take away 270 is how much? 50. Now, what are we going to do with? How do we find the overall vector? Remember that the overall vector starts at the origin and goes, whoops, click, draw. Sometimes it do be like that, but not now. How do we find that overall resultant vector? Aren't we going to add the two vectors together? And what form do we need the vectors in order to be able to add them together? Components. We need the components. So, let's get some components on this. How do you find the components for the plane? We need to find this x and this y. That's true. How do you find them? 325 cosine 70, comma, 325 sine 70. Now, do either one of those have to be negative? Because your calculator will spit out positive for both, but clearly from the picture, one of them's got to be negative, right? The x, the cosine one, has to be negative. I have to make that decision on my own. All right, next. Go find the x and the y for the wind vector. What do you got? We got a 50 in the corner there. 40 cosine 50. Sorry, just switched them. And 40 sine 50, right? Do either one of those have to be negative? The cosine, the x again, is negative. Add these two together, folks. Add them together. Grab your handy-dandy calculator. Negative 325 cosine 70 plus, I should just say minus 40, cosine 50. So I got negative 136.9. Can I get a witness on that? All right. And then I got sine 70 plus 40 sine 50. Whoops. Got this. Okay, right. 336, basically. If we're rounding to the tenths, it would just be 336, correct? Are you trying? Are you really participating? You're listening. I need more than that. Participation. Okay, now. So that's the overall vector, but they want to know what did they ask for? Maybe I should back up and see what the question actually said. Find the component form of the velocity of the airplane. The component form of the velocity of the airplane. Now, did I go too far for part A? I think that they need to be a little bit more specific, because when they say find the component form for the velocity of just the airplane, maybe they should have said that, just the airplane. Because that would have been the top part right there. Okay, this would have been your part A, and you would have typed this in a calculator. Find the ground speed and direction of the plane. Ground speed and direction of the plane. So now they want this big vector. They want to know the magnitude, and when they say direction, I'm going to say, since we started with bearing for both wind and plane, we should probably answer with bearing. So I need the magnitude, and I need the direction, or the bearing. So, yes? Okay, now the ground speed, okay, folks, is the speed of the plane as viewed from the ground. It is not how fast can the plane taxi on the runway. Okay? We're saying if I'm standing on the ground and I look up and I see this plane going through the air, how fast is it really moving? It's going faster than 325, I can tell you that, but it's not going as fast as 365 because the wind is not directly behind it. So, use your Pythagorean theorem. You got 136.9 squared plus 336 squared. If you're not participating, I don't know how this is going to get better if you don't participate in what we're doing. I got 362.8 miles per hour. Yes. If you don't take the square root, this plane will go real fast. Woo! 131,000. Well, yeah. Okay. So, how about the bearing? It would really help if I could find this angle inside the triangle. That angle inside the triangle. Well, you have two of the sides, right? You know that this bottom is 136.9 in the negative direction. You know that the vertical is 336. How are you going to find that angle? Inverse tangent, right? Opposite, over, adjacent. That angle inside there is 67.8 degrees. 67.8 degrees. But that is not helping me find the bearing yet, or answering the bearing. It is going to be useful. What are you going to do with that 67.8? I know you got a negative angle, right? Because you put the negative sign in there when you did the inverse tangent. It's okay. We still know that that angle inside there is 67.8. What are you going to do with the 67.8? I don't think I should subtract it. You're in this quadrant over here. You know this is 67.8. What are you going to do? Add it. 5. So you got 0, 90, 180, 270, and then 67.8. Oh my goodness. Well, then I'll only have to do the other half tomorrow. Okay. So 270 plus 67.8. 337.8. That is the bearing of the plane. So we know which direction it's heading. We know how fast it's heading, and we know which direction it's going. The ground speed is the 362.8 because it's the speed of the plane as viewed from the ground. Somebody standing on the ground is looking up. When they say ground speed, they're referring to somebody standing on the ground looking up and seeing how fast the plane's moving. See, the airspeed is only listed at 325 as the pilot's flying, but because it's getting pushed from behind, it's going faster than 325. That's why, they take into consideration these things when they fly, but pilots know that it's, they plan on it taking a little extra long. Because of, that's why planes, they land and they're not quite on schedule. Because things didn't quite happen the way they thought they were going to happen in flight. Or maybe they had more of the tailwind and they got there sooner. You arrived early. I don't know. I'll have to ask the State Highway Patrol. Can't pull over a plane. license and registration. Step out of the vehicle. I mean, don't drop. Okay, so where were we? Come on. Come on, put it in there. Throw me. There it is. There you go. You can post them and then ask them. Yes, you would kind of. Oh my goodness, it's like I say these things over and over, and people just ignore me. Yeah, I understand, but what I told you was we wouldn't be getting through all the notes, so. Okay. Remember, every day after lunch, I can answer questions for you too. Okay, we introduced you to this stuff. Last semester, parametric equations. It's where you're defining the two variables of a function based upon a third variable. So we can write x as its own equation and y as its own equation based on a third variable. Usually they like to use t. Okay? Yes. Okay. Don't drink it, but definitely try this. Oh, just wait. All right, now. So these are functions defined on some interval. They actually will create a parametric curve. Now, that's a very generic term because a parametric curve can be a straight line. Okay, but a parametric curve can be a lot of other things too. The equations are called parametric equations. This is also, you sound intelligent at parties if you hear these terms. Okay. The variable t is called the parameter. Yes, the parameter, folks. Okay, that's why we don't go to those. Okay. So t is called the parameter, and they usually define some interval I. They call it usually the parametric interval, but okay, the parameter interval. Now, these are some cool million-dollar words. When we give the parametric equations and the parameter interval for a curve, we have parameterized the curve. Yes, a parameterization of a curve consists of the parametric equations. So, we got all kinds of different versions of this to throw at you. Okay. Now, let's go to example 1. Okay, grab your graphing calculator. You will need your graphing calculator. Yes.
Okay.
Correct. Okay. Take your calculator, hit the mode button, the Edna button. Edna mode from The Incredibles? Yes, she designs all the super suits. Okay? No capes! Right. Okay. Now, at this moment, degree and radian don't matter to me. It won't change anything. But you can see one that says function. We're going to switch it over to parametric. For those of you with an older style, it'll just say par or something like that. Yes, yes. So you want yours to be switched over to parametric mode. Now, hit your y equals button. agree. You'll probably like this section, right? Because there's t's everywhere. Yes, we can T-pose a lot of these parametric equations. Okay, now, you'll notice that there is an x equation and a y equation. Now, the button that you normally use to get x on the screen, notice that it says x, t, theta, n. What do you think is going to happen when you press that button this time? It's going to give you a t. It won't give you an x. Okay, you thought what? What did you think? What was that? Oh, no, that's a theta. You know, if you use it a lot, maybe it got rubbed the wrong way and, you know, it looks like an E, but, yep, x, t, theta, n. So, in this particular mode, it will only generate a t. Okie dokie. I need you to graph a few functions. So, go to your x1, and you need to put t squared minus 2. T squared minus 2. And then for y1, you want 3t. Alright, do we have that part? Just like that, t squared and 3t. Okay, now go to your window. Still trying to find it? Oh, okay. I don't have batteries in this one. I'm trying to get some. Okay, so T-min and T-max, we're going to change those based on what we saw on screen over here. For letter A, what are we going to choose? -3 for the minimum and +1 for the max. Okay, so choose that. -3 for the min and +1 for the max. Now, whatever you do, let's just, for now, not mess with the T step. I know it's a nasty, ugly, weird number, but that's what it defaults to, and if you start changing that, you might go, wait a sec, what happened to my graph? Okay, things start disappearing. 0.1 should be good, 0.13, somewhere in that range should be fine. Okay? Now, they haven't specified anything about x mins and maxes or y mins and maxes, so I'm just going to leave those at the standard -10 to 10. Now, go to your graph. Yes? You got it? Okay. Alright, let me
Okay, she only had 0.1.
Go back and change it. Change it to -2 to +3. -2 to +3 for your min and max on T. Right. -2 to 3. So window, -2 to 3. Okay, we just had it on the screen. Okay. -2 to 3. Just write it down as you're going. As you're taking your notes. I'm going to say no. You're okay on that. Okay? Well, I'll show you something in a minute. Okay. let's see here. So we had that picture right there. Everybody have that picture? Anybody? Any questions on getting the picture like that? Okay. How about negative 3 to 3? Let's go negative 3 to 3. Change your window. Don't jump out, but change your window. Get that picture? So we got these three pictures. That's why you didn't have to write it down, because I already had them in the notes. But you notice I skipped over it really fast? Yeah, you did. I was like, oh, they won't pay attention. Okay, so those are the three pictures we should have ended up with. The X-min and X-max were left at negative 10 to 10. So those don't indicate. So we had the negative 3 to 1, right? Negative 3 is less than or equal to t, which is less than or equal to 1. Then what was the next one? Negative 2 to 3, and then negative 3 to 3. So we had those. Okay. We've done some of this kind of work before, so this shouldn't be, these first two examples here might not be that tough. When we get to the example 4, that might be new territory for us. Eliminating the parameter. All we need to do is solve one of the equations for t, and then substitute. So for instance, if we take the x equation and solve for t, how would we do that? Subtract 1 and divide by negative 2. Nicely done. Now, we come over to our other equation for y, and we replace the t. Yes, we did. So now I want you to simplify it. Go. You can distribute the negative to the top or distribute it to the bottom, whichever you prefer. But you can't do it to both. Can't do it to both because if you're distributing the negative to the top and to the bottom, you're multiplying by positive 1. Clearly, this is a negative 1. So you can only distribute it to the top or to the bottom. And since I had a negative down there in the bottom, I figured I might as well get rid of it. Okay, now what? Oh my goodness, no. Alright, so this is 1/2 x minus 1/2. It looks like we have a couple like terms that we can add together, folks. I'm pretty sure you guys know how to take 2 and add it to negative 1/2. What do you get? I know some of you wanted to cancel out these 2's back here, folks. It's not being multiplied, it's being added. Y equals 1/2 x plus what? 1 and 1/2. If you want to say 1.5, if you want to say 3/2, I don't care. It's okay. Okay, what was the question? Are we stuck on what we did here? Somewhere? Now would be a good time to ask me. Thought you were dabbing for a second. That was, it was just kind of a sneeze. Yeah, sneeze there. Okay. Okay, question 3. I know. Go to lunch. Just because you think you have the right to eat.